on, I should mention, is that Python doesn't really need too much in the way of nested loops. And once we get into areas where we do, they start making a lot more sense because you're iterating over stuff within stuff. So it makes a lot more sense. Like, for instance, for every line in the document, for every word in the line, right? So it becomes a lot easier when you handle it like that. So most of the stuff that we do on the exam will mostly be single for loops, stuff that's much more closer to the last assignment than assignment 3. Why do I torture you with that for assignment 3? Because I feel like it's good practice. It's good to build up your muscles, so to speak. So let's talk about turtles. Now, turtles are great because they give us a great way to learn about all of the concepts we learned about in a different context, especially the loops. So let's go ahead and talk about each of these. So our program always starts out in the same way. Import turtle, and then Bob is equal to turtle.turtle, or whatever you want to call your turtle, right? I like to call my turtle Bob because, like I said, it's 3 letters and 1 syllable, so it's very easy to type and very easy to say, right? So turtle.turtle, this will create a new turtle and give it the name Bob, okay? Over here, this is a completely optional step over here that I like to do, where I'm going to turn Bob into a turtle instead of an arrow, right? So if I run this, bob.shape, right, now Bob's actually a turtle on the screen, right? So now he's actually a turtle as opposed to an arrow. So that looks much better, I feel. Now, so you're always going to have these first 2 lines for a turtle program, and this last line is always going to be turtle.done. If you're working in the interpreter itself, right, if you're actually like programming things and if you're actually like working in like, in idle and doing this, right, saying, hey, import turtle, right, if you're working in here where basically you're doing it line by line, you won't need turtle is equal to done. Import turtle. And now what the import statement does is that it goes and finds a module called turtle, right? Code that we normally don't load into our Python program. Why? Because there's a lot of Python libraries out there, and if we loaded them all, your computer would actually kind of panic with all this stuff that it's had loaded. It would take up, many hundreds of megabytes of stuff probably, if not gigabytes. Yes? What's the capital T? Yeah. It indicates that we're creating a turtle object, which is something we get into much later. But for right now, just know that those are the magic words to create a turtle. Okay? And the capital T is to denote that it's not the turtle module, right? So here we're just loading in the turtle code into our program because we only load what we need. We can either load everything all at once. That's one way you can design a programming language. Load every feature. But guess what? That makes your programming language huge and hideous and unable to be held. Or you can just simply load a minimal set of stuff that's most of the stuff you need, like for loops and some basic math functions. And then as you need stuff like graphics, you can load that in. Or similar with a server. Like I believe to load a server, it's like import HTTP server, and that's it. And voila, you can use the server in Python now. All right, so we've loaded the turtle code, so that's saying now we can use it. And now we create a turtle called Bob. And so straightforward. Now, turtles are fairly straightforward. We just give them commands, and they essentially draw, right? They are like dragging a little pen behind them. So we can say bob.forward, and then we can tell them how far we'd like to move. Let's go ahead and move them forward 100, and I believe these are pixels. And so we run it, and Bob then moves forward 100 pixels. Right? Right? But just moving forward is not too exciting. Right? We need to be able to do a bit more than moving forward, right? Especially if we're in a 2-dimensional. We'd like our turtles to be more than 1-dimensional, maybe 2-dimensional, right? So Bob.right will turn him 90 degrees to the right, right? So we're telling him to move forward 100 pixels, then turn 90 degrees to the right, right? He moves forward, and then he turns 90 degrees, right, to the right. He was moving this way, and now notice that the turtle's pointing down, right? The little turtle head's pointing down. All right, so if we follow that up with telling him to move forward again, let's tell him to move forward 100 pixels again, right? And notice that it actually animates. We can set the animation speed, but for right now, that's not too important, right? He moved, and so what the turtle's doing is that he's following the exact directions that I'm telling him to do. I'm telling Bob, move forward 100 pixels. Turn right, 90 degrees. Move forward 100 pixels. Makes sense so far, right? So, if I told him to turn right again, and then to move forward 100 degrees again, we run this. I told him move forward 100 pixels, turn right 90 degrees, move forward 100, turn right 90 degrees. So he was moving this, he was down this way, so he goes this way. I think that's from your perspective this way, right? And then we told him to move forward another 100 pixels. Right? And if we do this a couple more, and if I copy this 2 more times, right? Paste, paste. Right? Do this a grand total of 4 times. What does he do? He goes in a square, right? I told him to go forward 100 degrees, 100 pixels, then turn right 90, 100, turn right, 100, turn right, and move forward. Yes?
Instead of just copying and pasting, you should also use a while loop to animate that.
Yes. In fact, that was the next step. I'm going to do a for loop now, right? Because for loops are great for when you want to know how many times to do this. So now I'll use a for loop to do that. Rather than going forward, I'm going to go ahead and tell him to go ahead and, let's see, for I in range 4, repeat the following steps 4 times, right? Move forward 100, and turn right 90 degrees. Oops, forgot myself my colon, so. Right? Repeat that block of code 4 times, right? Move forward 100 steps. Turn to the right, move 100 steps. Turn to the right, move 100 steps. Turn to the right, move 100 steps. Turn to the right, right? Notice that we move forward, turn to the right, move forward, turn to the right, move forward, turn to the right, move forward, turn to the right. Right? He turns to the right 1 more time, so he's facing the way he started. We can, and mind you, because these are numbers, we can do variables instead. So I can say like size is equal to, 100. And then I can put size over here. And, now it runs the same exact thing, except if I want to make my size twice as big, I can say, let's go ahead and make this 500. Right? Now we'll move forward 500 pixels. Yeah, the space is infinite, and even if your window doesn't fit it, right? It's an infinite coordinate plane. He's at 0, 0, right? So he moved forward 500 spaces, and then he moved down 500, right? So be aware, this little guy can move, right? Right? Even it becomes more obvious if I bring it up to 1,000, right? Boom, boom, right? He's going places, and there, he's back, right? Why does he always come back? Because it's a square, right? He's got to come back where he started. He's moving away from us in right? He moves away in this direction, and then he moves away. sorry, he moves away to the right, he moves away, down, then he comes back to the left and back up, right, canceling out his movement. Right, that makes sense to everybody? He canceled out his movement. So he ends up in exactly where he started. You don't have to end up where you start, but it certainly makes it much easier to do. All right? So, now, there are, oh, and by the way, if I, bring this up to, if I do range, 50 over here, this is just going to go on for a while because, here he goes, and then he goes again. Drawing over the, and as you can see here, this demonstrates something. This line's only a specific, it's the same with fit, and he's pretty, Bob's a pretty precise artist, so if he draws over a line, he's going to draw over it the exact same way, and the ink isn't going to smear, right? You draw over a line that you already have, no worries, right? This will take a while. So, and if you cancel this, by the way, if you cancel it while it's in the middle of drawing, you'll get an error. That's perfectly fine. It's just kind of throwing its hands up saying, you took away my paper. I was still drawing, Of course, squares aren't really the only thing we can do. Let's bring this down to a much more reasonable size. All right. And now let's go ahead and, so now it's back to a reasonable size, right? Reasonable sizes mean that he can go quicker, right? There is a way to just make it go instantaneous, but it's much more fun to watch him actually scurry around, so we're going to stay there. All right, so let's take a look at changing this up, because the angles really are what matter here for whatever shape we did, right? If we wanted to move, if we wanted to do a square, right, we're doing essentially going 90 degrees. If we want to change this up to a rectangle, I'm not saying what number has to go in here or what do we have to do, but what conceptually has to change to make it a rectangle? Two of the sides have to be different, right? Right. Technically, actually, a square is a rectangle, but, aside from that, to make a rectangle, two of the square. So one thing we could do is that, saying, hey, every other time you move, you should totally go further. So we can do that with an if statement over here. And we'll just do this, and then I'll explain it. If I mod 2, right? So if I over here is even. Yeah, you thought this was all going to be drudgery. No. I have to do the drudgery first, and then we get to have fun. Okay, so thanks for sticking it out. Because, right, this is the fun stuff. So if I is equal to, if I mod 2 is equal to 0, we're going to say move forward, right? So if I is even, we're going to move forward size. Else, we want Bob to move forward 2 times size. Okay? So what this is saying here is that if this I is even, right, I is going to be what? It's going to be 1, 2, it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right, and so on and so forth, up to, but not including 50, right? Here we're saying if I mod 2 is equal to 0, right, if I is even, if we're on an even step, move forward size. If we're on an odd step, we're going to move forward twice size. And then turn right regardless. So notice here he does a rectangle, right? I is even, so 0 is even, so we go this way. 1 is odd, so we go twice size, right? Then I is then 2 is even, so we go this way. 3 is not even, so we go up more, and so on and so forth, right? It alternates, right? So you can change your directions like that. Now, that's pretty nice, right? So that's one thing. So that's one way to get him to draw a rectangle, right? All right. Oh, and there isn't just right. You don't have to. I mean, first off, you could just use right, and go negative 90 degrees to the right. That means, of course, turn left, right? So now Bob's turning left all the time. But that'd be really frustrating to have to do to have to say, hey, I want you to turn negative 90 to the right. That's really frustrating. So of course, can you guess what the command is to turn left? Left, yes. The element of least surprise in programming languages is something that is extremely important. In other words, the function names, the names for variables, and the names for functions, and the way things work should be the least surprising way, right? So now if I turn left 90 degrees, it does exactly the same thing. Okay? Now you might you might also be like me, and you might be going, left and right, those are like 4 characters and 5 characters long. I'm lazy. Isn't there a quicker way to do it? Yes. So you can shorten that to LT for left and RT for right. You know, left turn, right turn. Both do exactly the same thing, right? One just happens to be a bit more readable, right? And in my class, and for you guys, I will just generally write it out because it's I'm writing this once, but it's getting read like 100 times, so it's much more important that it's easy to read. All right? All right, so I promised that the math here, right? I know you guys weren't planning on being quizzed in geometry, but that's exactly what we're doing here. So Bob.Forward, let's tell him to move. So we're going to go back to moving forward size, right, no matter what. So this going 90 degrees and turning right 90 degrees gave me a square. What do I need to do to get a triangle? Right? So how many degrees are in a triangle? 180. Right? 180. So let's see. If I go 60 each time, will that get me a triangle? Oh, no, that gives me a hexagon. It gives me a hexagon. Why? Well, because he's doing exactly what I said. He's going he's going 60 degrees. Right? Yeah, 120. So if I turn 120, let's see what happens now. Right? He turns 120 degrees, which, by the way, makes this inner angle 60. 120, 120. So it kind of gets flipped around there. Not too much to worry about. And the reason, and why is that? Well, because you got to think of it in terms of 360 degrees, right? A triangle has 3 sides, so the 3 turns I make have to add up to 360 degrees. Make sense there? All right. What else can we do? So first off, I'm not a fan of the Model T way of doing things. You can have the turtle any color you want, so long as that color is black, right? That's a bit boring. We need to be able to do more. If we're doing graphics, we need to have color, right? So Bob. So we can do 2 things. First, we can change the color of Bob, right? We can turn him into and it's actually surprisingly, again, like this. Bob.color is now green. And this is just setting his color to green. And that turns both Bob green, and it may be a bit hard to make out on the screen over there. It makes what he's going over green too, right? It changes both him and his pen color to green. If, however, you like Bob being black, you can just change the color of his pen too. And now he's outlined in green and he's drawing. Okay. Which brings me to now our first aside, which is that we need to discuss color, which is hard. Color's terrible. It is ridiculously hard. XKCD, which, by the way, if you've not seen XKCD before, the webcomic, you should take a look. Let's see, color models, right? Evolution of my understanding of color over time. Grade school, color is 3 primary colors mixed together. A rainbow, and each wavelength is color. Unknowable, maybe I see as blue, you see as, right? 3-ish primary colors mixed together. RGB, RYB, CMYK. A mix of infinite wavelengths filtered through 3 eye pigments. Abstract multidimensional gamut. And then it ends up as hopefully somebody else's problem, right? Color is actually pretty complicated. In fact, like one of the things that has to do with the laptop you're using is that so your laptop may have only a certain color range. It may not be able to display all colors. It certainly that somebody else's laptop might be. And there's also like the blue on my screen might be blue different than the blue on this screen. I mean, like this is like blurry up there, and that's much darker than what I have over here, right? So color's actually kind of tricky. First off, if you see it, but that doesn't get real. But let's go back up this chain. Just color is hard, and unless you're worried about like professional graphics, don't worry about it too much. But once you're getting into professional graphics, you really have to care. And like when we're talking about graphic artists, not like necessarily modeling things. So 3-ish primary colors mixed together. RGB, right? So RGB is 3 colors: red, green, and blue, and that's the way we define colors in on computers. We have red. We basically say that each color is a mix of a certain amount of red, a certain amount of green, and a certain amount of blue. Okay. Now, typically, the way this is done is that we use color selector. Is that we let's see, color picker. Why not? There we go. Right. Typically, you might see like something like this for it, and the reason being is because RGB 8. Ooh, wow, this really doesn't look great on my screen at all. Oh, but then they have these numbers over here, by the way. Notice that they all have these weird numbers with F's and letters in here, right? So let's talk about the way colors are defined in computers. Colors are defined in computers by using something called, they're used by 3 values, one for red, one from green, and one for blue, somewhere with the range of 0 to 255. Okay? 0 to 255. Incidentally, that's 8 bits of data. It's just kind of classical the way it is. 8 bits of data for each of them. So, and furthermore, like where's the F's and the A's coming in? Well, it comes from the fact that basically, let's see, does Python do this? There we go. That basically we're using something called hexadecimal format, right? Numbers we typically see over here are in base 10, right? This is a base 10 number, right? Ones place, tens place, hundreds place, thousands place, 10,000s, and so on and so forth. On the other hand, this is hexadecimal format. 0, A, let's see, 0, 0, 0A, that gives me 10. So hexadecimal format is base 16. So it has not 10 digits, not just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, but not just 1 through 9, but it also has A, B, C, D, E, and F, where A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So you have your ones place, and you have your 16s place. So, for instance, 20 is 2 16s. 0x 20 is 2 16s, meaning 16 times 2, which is 32. And this over here is 16 times 16 plus 2, which would be 34. Right? Now, do you need to know hexadecimal format? No. But it's something that your computer supports. And it's also important to realize, though, that, so let's go back and take a look at this number over here that they have over here. Let's go ahead and bring this up. 9E2525. So this is 3 different values in here. 9E2525. That is the code for this color. Okay? That means that there's 9E, which is 0x 9E, 158 amount of red, 25 blue and 25, sorry, not 25 blue. That's 0x 25, which is 37 blue and 37 green mixed together. That's how it typically works out. Now that's the classical way of doing color. It turns out that that because this was designed for basically to be a bit easier, there's a second way to do it, and I think that this is the default way to do it. So 0.5, let me so say 0.100. Let's see if that works. Yep. So there's the default way that's built into the default way that is built into Python and for our turtle library to do stuff is that it says, well, actually that 0 to 255 is a lot for people who are learning the first time, right? Because Logo, this was designed for something called Logo, which is a programming language from the 1960s, and it was designed to teach, little kids how to do programming, the turtle module. But it's still very useful because it's very useful for teaching us how to do our programming paradigms. So we can set up the color to do, so we can set up the color to be a bit easier. We just give the color a range between 0 and 1. It's a float. So I say, like 0 being no intensity in that color, right? So it's being black. So it's all black because we have no red mixed in there. 2, we can do, whoops. No, I don't want to. 1, 1, and 1, which is the colors all the way turned up, which is white, right? So if I say, right, so you just give it a value, say, hey, I want a lot of red, half of green, and as much blue as possible. It gives us this nice fuchsia color. Nice purple color over here. Okay. So we can set our colors with this. That's pretty cool. All right. So now let's go ahead and do the last bit before I let you go off on your own and draw your own figures. All right. So the last bit on our own is that because we're in a for loop, that means we can modify the stuff in the loop as we're going through the loop. So let's go ahead and say Bob is going to move forward, not size, but size plus I times 10. All right, so let's think about that. That means the first time Bob moves, he's going to move forward 10. He's going to move forward 100 plus 0 times 10, right? Then he's going to move, so he's going to move forward 100. The next time he's going to move forward 100 plus 1 times 10, 110 spaces. Then the next time he's going to move 120, and then 130, and then 140, and so on and so forth. So let's see what goes on when he does that. Oh, that's pretty cool. He kind of like spirals it out there, right? Because he's moving 10 more each time he turns, right? Notice that he's not actually created a triangle, even though it's triangle shaped, because he's turning the same amount each time, right? But it's not a triangle because he's never really connected any lines, right? It's just like a triangle shaped spiral, right? He moved forward 10 over here, then 110, and then 120, and then 130, 140, right? It got bigger each time he went around. Everybody see kind of how that worked out? Right? Let's go ahead and change that to Bob turn left 90 degrees. That's still going to be a square shape, but now it's going to be a square spiral. Because remember, he's now moving forward because, right, the reason he was able to connect everything was because he was basically moving forward the same amount. He was moving the same direction each time. And here he's moving a different direction each time, a different amount each time in each direction. All right? All right. And now, one last thing before we go ahead and let you go on your own. There's no reason why I can't put this in our for loop and change it too. So let's go ahead and say red and blue. Let's go ahead and say red and blue, so 0. I'm not going to change the, so it's going to start out red, and then each time we go through this, I want to subtract maybe I times 0.01, right? Because it's between 0 and 1, right? So it's going to go all the way. So this will subtract 0.1 each time. And then over here, I'll add 0.1 times I to the color. So now let's see what happens. So everybody gets everybody see what's happening? I'm saying let's change the color slowly. The red is going to decrease while the blue is going to increase. Oh, bad color sequence. Oh, yeah, because I brought up the blue. The blue got brought up before it was 0.1, right? That was too much, so got it up to 1.1. You can't go above 1 in a color. Right, so the blue is slowly coming up while the red is going down. So the color is changing, just very subtly. Maybe we'll need to bring it up faster next time. Yep, it's kind of just getting into a now brownish color, which isn't that all that appealing. So let's go ahead and bump it up, right, to 0.2. Right, now why do I get a black line right over here to begin with? Because it moves forward 100 spaces before I tell it to change the color. So to avoid that, I should probably move the change color beforehand. Oh, now we got into the reason it's coming out brown is because I didn't increase the blue. What color did I increase? Green. Right, it's red, green, blue. So let's go ahead and take this and move it over here. And ta-da. All right. So while this is coming out, let me describe what I want you to do today. Today's in-class assignment is fairly straightforward. Get turtles working on your laptop if you brought it with you, and draw a shape. Draw something shape. It can be a square. It can be something spirally like this. You can make it as intricate as you want. You can look up examples online to see. But right now, I just want you to have a bit of fun with this. Okay? Submit what you have, and then turn it in. There should be a turtle, Dropbox under assignments or under quizzes that you can turn in. But I just want you to play around with turtles and basically see where it's working, because I know that some older Macs can have some trouble with this. All right.